In this video, we're going to talk about the transformation of functions. And one of the first things I want to kind of point out to you, sometimes you think, well, why in the world are we learning this? Or what do we need to know this for? And so I found two YouTube videos. One is kind of a fun one. The first one is on morphing. And then the second one's actually from NASA and how NASA has used the idea of transformations of functions in the development of some of their airplanes and aeronautical vehicles. And so you may want to take a look at those so you can get an idea of why in the world do we need to know this stuff. And you may say, well, I'm never going to be an engineer. But if you're interested in things like animation and things like that, then this is a very useful concept to you. In terms of transformations, there are really two types of transformations. And in total, there are 6 different things that can occur to a graph. The first set of transformations we call rigid transformations. In a rigid transformation, the position or location of the graph changes, but its basic shape remains unchanged. And there's 3, or really 4, rigid transformations that can take place. You can have a vertical shift, a horizontal shift, a reflection about the x-axis, or a reflection about the y-axis. And we're going to talk about kind of what each one of those things would look like, and how do you know that it occurs as we proceed through this video. The second type of transformations we called non-rigid, and with non-rigid transformations, it actually causes a shape, the shape of your function or graph to change, causing a distortion. Again, it's that idea of morphing. And you can have, there are 2 non-rigid transformations. One is called a vertical stretch or compression, and the other is a horizontal stretch or compression. And so if you have a function, basically all 6 of these transformations are controlled by 4 different parameters or 4 different constants. And the location of that constant or the position of that constant in the function is going to determine which type of transformation is occurring. So in general, in a function, you have a times the function f of bx minus h plus k. And these are pretty standard constants that you'll see. So again, you have 4 constants here. You have a, b, x, and k. And pretty much they can be any number within our number system. They can be positive, they can be negative, they can be fractions or decimals. And again, the location and the position within the function description identifies which transformation is taking place. So let's talk about each one of these letters. And we're actually going to start with K. It really doesn't matter where we start. So first, we're going to talk about the shifts that can occur vertically and horizontally. For a vertical shift, it's determined by K, which was, if you'll remember, in our overall function here, where you have, kind of jumped off the screen there. You have A times the function bx minus h plus k. The k is oftentimes kind of tagged at the end, almost as an afterthought. It's outside the parentheses, whereas the h is inside the parentheses of the function. And so k determines whether you're going to have a vertical shift. And the idea of a shift means you're just moving it from one location to another. It's vertically, so you're going to be moving either up or down. And hopefully common sense tells you that if it's positive, you're going to move up, and if it's negative, you're going to move down. Horizontally, the horizontal shift, moving it around, is determined by h. But you got to be careful because in this formula, notice that it's minus h, or we view that or read that as the opposite of h. So the horizontal shift is determined by the constant that is inside the parentheses with the function. And a lot of students tend to make a sign error with that because of that minus in there. And so one of the ways to avoid the sign error is to take the expression in the parentheses, set it to 0, and solve for x. And then if you look at the value of x, whether it's positive or negative, that tells you whether to move left or right. Again, vertically, you're moving things up and down. Horizontally, you're moving it left and right. So again, be careful because of that minus sign in the expression, because you can make a sign error and move in the wrong direction. All right. Next, we're going to talk about the reflections, or sometimes they're also called flips. And again, thinking about our generic expression here, the reflection on the x-axis is determined solely by the sign on A. I really want to focus on whether that value out in front of the function is positive or negative. If it's positive, nothing's happening. It's the same as the parent or as the basic function that you're given. But if it's negative, that causes a flip. So let's think about that for a minute, kind of think about what that might look like. If your original graph, for example, is like a good old basic everyday parabola, like this basic U-shaped curve. And in good old everyday form, that's just plain old f of x equals x to the x squared. Well, if I put a negative in front of the function, okay, so this will be like having just plain old a times f of x. But if I put a negative, like negative a times f of x, so that I would have the equation f of x equals the opposite of x squared, what happens then visually is my graph flips over on the x-axis. It's as though you're rotating, you want to think about it, you're rotating it about the x-axis. So when you have a flip, it's as though you're rotating it around the x-axis. Sort of think about like a water wheel, how a water wheel goes around and around and around on a post. So that's a reflection or a flip on the x-axis. Again, sometimes students get that confused, and I have kind of a stupid little saying that sometimes helps students remember it. A, you reflect on the x, you get the ax, because ax spells ax. So A, the sign of A determines whether you reflect on the x, and you get the ax. B, the sign of B, again, we're solely worrying about the sign, whether it's positive or negative, but the sign of B determines whether or not there's going to be a reflection on the y-axis. Okay, so again, if it's positive, nothing happens, but if it's negative, you reflect it on the x-axis. So let's see if we can take a look. I can try to sketch you a picture here. So let's say, for example, I have maybe a function that looks like this. Okay, so this would be f times b of x, or f of b of x. And then if instead I have a negative on the b, let's think about what would happen. So if I have f of negative bx, what happens is it causes a reflection on the y, and my graph gets flipped across the y-axis. Now, again, what's happening there, if you want to think about it, is it's like you're turning around, you're spinning around the y-axis. Okay, so it's sort of like a merry-go-round now. You're going around and around and around and around as if you were spinning. Again, I have a stupid little saying that may or may not help you, but again, students have trouble remembering it. So one of the things I use is, again, by. If b is negative, there's reflection on the y, and you get the by. Okay, so b is negative, you have reflection on the y, you get the by. Again, it's kind of stupid, but maybe that'll help you remember that information. Continuing on, then we need to talk about stretches or compressions. And again, in that generic form, A and B play a role in whether there's going to be a stretch or a compression. So A and B actually play two roles. The A determines whether there's going to be a vertical stretch or compression. And again, now you're worried about the value, the numeric value, or the absolute value of that. You're not worried about whether it's positive or negative. So if the absolute value of A is between 0 and 1, typically a fraction, you're going to have a compression so that the graph kind of gets flatter and fatter. If it's equal to 1, nothing's happening. If it's greater than 1, there's a stretch. Think about like stretching a rubber band. If you try to stretch a rubber band, it gets taller and skinnier. Or think about yourself. If we were trying to stretch you, you would get taller and skinnier. But if we tried to compress you, you would get shorter and fatter, unfortunately. So the vertical stretch or compression is determined by A. The horizontal stretch or compression is determined by B. And again, at this point, we're more concerned with the numeric value, not the sign. So you're looking at the absolute value of B. And this one seems a little bit backwards because when you start thinking about doing the horizontal stretch or shrink, we think about it in terms of 1 divided by B is actually the factor by which we would stretch or compress. And so if B is between 0 and 1, it's typically a stretch. And if it's equal to 0, if it's equal to 1, nothing's happening. And if it's greater than 1, there is a compression. Okay, so that's kind of an explanation of the different transformations that can occur. And we're going to take a look at, in the next video, some examples from a graphical standpoint as well as from an algebraic or an equation standpoint.